Me. How much more of the global sea level would rise, if all the glaciers and all the polar ice caps melted? AIE. If all glaciers and both polar ice sheets melted, scientists estimate that global sea level would rise by about 60-70 meters. Earth's ocean coverage would increase from 71% to about 75-76%. That's an increase of roughly 4-5 percentage points of the planet's surface. This dramatic change comes from the 60-70 m sea level rise documented by NASA and USGS. Me. I've noticed that winters here in south-central Ontario are bringing snow in earlier with large dumps. Can this be because of global warming, melting polar ice sheets and melting glaciers? AIE. You're noticing something a lot of people across southern Ontario have been talking about: earlier snowfalls and big, intense dumps. And yes, this can absolutely be connected to global warming, but not in the simple melting ice, more snow way. The real explanation is more interesting and a bit counterintuitive. Why warmer global temperatures can mean more early season snow. Climate change doesn't eliminate winter, it supercharges it in certain ways. One, warmer air holds more moisture. For every degree Celsius of warming, the atmosphere can hold about 7% more water vapor. More moisture, bigger snowstorms, as long as temperatures are still below freezing. This is why places like Ontario can get heavier early season snowfalls even in a warming climate. The Great Lakes are staying warmer for longer. South-central Ontario sits downwind of Lake Huron, Georgian Bay, and Lake Erie. Warmer lakes in November and December mean more evaporation, more lake-effect snow, bigger, wetter snow dumps. This is one of the strongest local climate signals in the region. Melting Arctic ice reduces the temperature contrast between the poles and the mid-latitudes. This weakens the jet stream, making it wavier and slower. A wavier jet stream can pull Arctic air south earlier in the season, stall weather systems, create long-lasting snow events. So you can get cold and moisture at the same time, which is perfect for big snowfalls. Melting glaciers and polar ice sheets. Yes, they play a role, but not because they add water to the atmosphere. Their melting contributes to Arctic amplification, the Arctic warming faster than the rest of the planet. Jet stream disruption. Changes in storm tracks. These shifts can make early season snow more likely in parts of Canada. The bottom line: your observation fits what climate scientists expect. Me. Seemingly, the western part of Canada is experiencing more droughts. AIE. You're noticing a real, well-documented pattern, and it's not your imagination. Western Canada has been trending toward more drought, while Eastern Canada has been seeing more rain, more snow, and more intense storms. This divide comes from a mix of geography, atmospheric circulation, and how climate change affects each region differently. Canada is split by two major climate systems. Canada is so large that it sits under two very different climate regimes. Western Canada, influenced by the Pacific Ocean, but blocked by the Rocky Mountains. Dry interior climate. Strong sensitivity to changes in Pacific patterns, El Niño, La Niña. Eastern Canada, influenced by the Atlantic Ocean, Gulf of Mexico, and Great Lakes. Wetter continental climate. More access to warm, moisture-rich air masses. This natural divide becomes more extreme under climate change. Western Canada is warming faster and drying out. Several factors push the west toward drought. The Rockies block moisture. Moist Pacific air hits the mountains, rises, cools, and drops its moisture on the west side. The interior, Alberta, Saskatchewan, BC interior, gets dry air descending on the other side. Climate change intensifies evaporation. Warmer temperatures mean more evaporation from soil, faster drying after rain, more heat waves. Even if rainfall stays the same, the land becomes drier. Shifts in the jet stream. A wavier, slower jet stream can lock the west into long dry spells, persistent high-pressure domes, heat waves that worsen drought, El Niño and La Niña cycles. These Pacific cycles strongly affect the west. El Niño warmer, drier winters. La Niña colder, sometimes drier summers. Climate change is making these swings more extreme. Bottom line. The reason Western Canada is getting more drought while Eastern Canada gets more rain and snow is a combination of the Rockies blocking moisture, different ocean influences, Pacific versus Atlantic/Gulf, a warming atmosphere holding more moisture, jet stream changes, stronger storm tracks in the east, faster warming and drying in the west. Climate change doesn't affect all regions equally, it amplifies their natural tendencies. California also seems to be getting more droughts. AIE. You're absolutely right, California has been trending toward more frequent and more intense droughts, and the reasons overlap with Western Canada's drought pattern but also have some uniquely Californian twists. Here's the clearest way to understand what's going on. California is warming faster than the global average. Warmer temperatures mean more evaporation from soil, faster drying after rain, hotter, longer heat waves. Even if rainfall stayed the same, California would still get drier because the land loses water faster. This is a major driver of the state's mega-drought conditions. The Pacific Ocean is shifting storm tracks northward. California relies heavily on winter storms, atmospheric rivers, for its water supply. Climate change is nudging these storms farther north, toward Oregon, Washington, and British Columbia, away from central and southern California. This means fewer storms reach the state, and the ones that do are more erratic. The Sierra Nevada snowpack is shrinking. California's water system depends on snowpack acting as a frozen reservoir that melts slowly through spring and summer. But warming temperatures cause more winter precipitation to fall as rain instead of snow. Earlier snow melt. Smaller snowpack overall. This reduces the slow, steady water supply California historically relied on. High-pressure ridging blocks storms. A persistent pattern known as the ridiculously resilient ridge has become more common. It's a dome of high pressure over the northeast Pacific that deflects storms away from California, locks in long dry spells, intensifies heat waves. Climate change makes these blocking patterns more likely and more persistent. Drought and wildfire feed each other. Drier vegetation, more fuel. More fuel, bigger fires. Bigger fires, damaged watersheds. Damaged watersheds, worse drought impacts. This feedback loop is now a defining feature of California's climate. When it does rain, it's more extreme. This is the paradox. California is getting fewer storms, but the storms that do arrive are often much stronger because warmer air holds more moisture. This leads to atmospheric rivers, flash floods, mudslides, long dry periods punctuated by extreme wet events. It's a climate of extremes, not balance. It's the same broad pattern affecting Western Canada, but amplified by California's geography and dependence on winter storms. Why does warmer air contain more moisture? AIE. Warmer air can contain more moisture because of basic physics, specifically how temperature affects molecular motion, evaporation, and saturation vapor pressure. The search results you triggered back this up clearly. Here's the explanation in a clean, intuitive way, grounded in the sources. Warmer air has more energetic, faster moving, molecules. Temperature is really just a measure of how fast molecules are moving. When air is warmer, its molecules have higher kinetic energy, which gives water molecules more freedom to stay in the vapor state instead of condensing. This is exactly what the Institute for Environmental Research and Education describes. Warm air's increased kinetic energy allows for greater spacing between air molecules, providing more room for water molecules to evaporate and exist as vapor. Increased kinetic energy. Greater spacing between molecules. More room for water vapor. Warm air expands, creating more space between molecules. As air warms, it physically expands. More space between molecules means water vapor can remain mixed in the air without condensing. This is supported by the physics explanation that warm air molecules are further apart due to expansion. Air expansion. Molecules further apart. Reduced condensation tendency. Evaporation increases with temperature. Warm water evaporates faster than cold water because more molecules have enough energy to escape into the air. The University of Arizona notes that hot water evaporates 3 times more rapidly than cold water in their example. More evaporation, more water vapor in the air. Faster evaporation. More water molecules entering air. Higher vapor content. Saturation vapor pressure rises exponentially with temperature. This is the scientific core. As temperature increases, the maximum amount of water vapor the air can hold rises exponentially, not linearly. The true geometry science explanation confirms this direct, exponential relationship between temperature and water vapor capacity. Exponential vapor capacity. Higher saturation point. More moisture before condensation. A helpful way to visualize it. Think of warm air as a bigger container with faster moving molecules. It takes more water vapor to fill it to the point where condensation, clouds, fog, rain, begins. Cold air is a smaller container. It reaches saturation quickly, so moisture condenses easily. How does CO2 warm up the Earth? AIE. Here's the clearest, science-grounded explanation of how CO warms the Earth, with citations from the sources you triggered. The short version. CO warms the Earth because it absorbs infrared radiation, heat, that the Earth is trying to emit back into space. This trapped heat warms the atmosphere, the surface, and the oceans. This mechanism is directly confirmed by NASA measurements showing that rising CO reduces the amount of infrared energy escaping to space. Sunlight enters the atmosphere. Most sunlight passes through the atmosphere and warms the Earth's surface. The surface then emits this energy back upward as infrared radiation, heat. 2 CO molecules absorb infrared radiation. CO has special molecular vibrations that allow it to absorb and re-emit infrared radiation. This is why it is a greenhouse gas. Science feedback explains that CO's ability to absorb infrared radiation is a well-established physical property, known for over a century. CO re-emits heat in all directions. After absorbing infrared energy, CO molecules re-emit it. Some goes upward, eventually escaping to space. Some goes sideways. Some goes back downward toward Earth. That downward re-radiation warms the surface and lower atmosphere. This is the essence of global warming. Think of Earth like a blanket. Sunlight warms your body. A blanket slows the escape of heat. Adding more layers traps more heat. CO is one of those layers and we've been thickening it. Me. What's the largest man-made cause for CO2? AIE. The search results make this one very clear. The largest human-made source of CO is the burning of fossil fuels, especially coal, oil, and natural gas. Here's the breakdown with citations and a clean structure. The biggest man-made source of CO. According to global emissions data, around 90% of all human CO emissions come from fossil fuels and industrial processes. The burning of oil and natural gas is specifically identified as the largest contributor. Coal alone accounts for 41% of global fossil fuel CO emissions in recent estimates. So the single largest category is burning fossil fuels for energy. This includes electricity generation, especially coal and natural gas; transportation, gasoline and diesel; industry and manufacturing; heating buildings. Bottom line: the largest man-made cause of CO is burning fossil fuels, especially for electricity, transportation, and industrial processes. Me. Is coal a fossil fuel? AIE. Yes, coal is a fossil fuel, and the search results confirm this very clearly. Here's the essential explanation, grounded in the sources you triggered. What coal actually is. Coal is described as a non-renewable fossil fuel by National Geographic, formed from the remains of ancient plants that were buried and compressed over millions of years. Wikipedia also states directly that coal is a fossil fuel formed when plant material decays into peat and is transformed by heat and pressure over geological time. So coal meets all the criteria of a fossil fuel. Formed from ancient organic matter. Created over millions of years. Non-renewable on human timescales. Burned for energy. Why coal is considered a fossil fuel? Coal forms when ancient plants die in swampy environments. They become buried under sediment. Heat and pressure transform the plant matter into peat, then lignite, then bituminous coal, and eventually anthracite. This long, slow process is exactly how fossil fuels form. Quick confirmation from sources. National Geographic: coal is a non-renewable fossil fuel. Bottom line: yes, coal is absolutely a fossil fuel, created from ancient plant material and used widely for energy. Me. Then coal is the most polluting of all the fossil fuels. AIE. Yes, coal is the most polluting of all the major fossil fuels, and the search results you triggered back this up very clearly. Here's the science in a clean, structured way, with citations and some helpful context. Why coal is the dirtiest fossil fuel. Coal produces more CO per unit of energy than oil or natural gas because it contains more carbon and less hydrogen. When you burn a fuel, carbon becomes CO. Hydrogen becomes water vapor. Coal has the highest carbon content, so it produces the most CO. The R-squared energy analysis notes that coal contains a higher percentage of carbon than oil or natural gas, which is why it produces more CO when burned. What the data shows. Coal is responsible for more CO emissions than oil or gas globally. The largest share of fossil fuel CO emissions worldwide. Massive annual emissions, reaching 15.4 billion tons of CO in 2023. Statista explicitly states that coal is the dirtiest and most polluting fossil fuel and the largest climate polluter by far.